So to find the displacement, we have to take the integral, displacement is s, we have to take the integral of the velocity from 0 to 5. And when the velocity function is t squared minus t, that means we're increasing each of these exponent by 1 and dividing by that number, and then evaluating the integral between 0 and 5. So that means placing 5 in first and then subtracting 0. Works out to be 29.2 units, and we're not told what the displacement is measured in, so that's why I've just put units. Now the harder question is the part B, and let me just put that onto the screen here. Oops. See if I can fiddling about here. So the distance traveled in this case is the absolute value of the function, and that means we need to figure out when the function is positive or negative. So we need to figure out when t squared minus t is positive or negative. So I'm going to factor that and put it on the number line. So here I've put t on the number line, and it between 0 and 5. That's all we're worried about. And t minus 1 changes at 1. So there's two sections, negative between 0 and 1 and positive between 1 and 5. So that's why I've changed my integral into two pieces. Going from 0 to 1, it was negative, so that means I've got to multiply by a negative to do the same job as the absolute value. And between 1 and 5, it's positive, which means I can just take off the absolute value because the absolute value doesn't really do anything to a positive number. And then I integrate these separately, so we just got to be careful here with the signs. So each of these go up by a power of 1, and we're integrating between 0 and 1. Same thing right here, integrating between 1 and 5, and then plugging in my values and simplifying, you should get 29.5.